Okay, in this video, what we are going to do is we are going to build simple addition and check it, make sure it works. So here in the constructor, we're going to want to call a function routine generate question. And it doesn't need any of the parameters, and this doesn't exist yet, so the compiler's throwing an error. If I look at down here at this little drop-down menu right here, it gives me some options, and I'm going to go ahead and double-click it and generate this new method because I need it to happen first. I need it to happen. And it's just a quick, easy way for Visual Studios to generate a little bit of code for me. And eventually, I'm going to want to do addition, subtraction, multiplication, and division. So I'm going to try to build this accordingly. What I'm going to need is I'm going to need an integer, a, and an integer b. And I'm going to need another integer for a math operator. Right now I'm just going to hard code that to 0. A and B, really what I'd prefer is that the computer is generating random numbers for me. So what I need is, and values between 0 and 10. So what I need is a random number generator. And I'm going to go ahead and build one right here at the very start of my class. And the class that I'm going to choose is a random, which is a predefined class for the .NET framework that I can use in Visual Studios. And I'm going to call the name of my new random random. And I'm just going to go ahead and initialize it right here in line. So random equals new random. New is a keyword to call the constructor of a class. And it's going to return a new random for me. Now, inside the random, there's different parameters that I can choose. I scroll through this list. I can either have just a random initialized, or if I want to, I can pass in a seed. This is useful for testing purposes. Our program is rather small. We don't need to throw in a seed. Typically, the random is going to be generated with a seed from the system clock. Basically, the system clock is passed in so that every time we run this program, we get a pseudo-random seed, a fake random seed. That way, every time we run this program, our random generator appears to be random. Since the system clock is going to be different every time this is called, the random is going to be seeded differently, and therefore it's going to give us somewhat random output. And back to my variables here in the generate question, I'm going to initialize these and I'm going to use this random number generator that we just used, and I'm going to pick the next method, because that gives me an int. And picking that, I can scroll through the different options here. This one gives any non-negative integer, which for the purposes of this program is too big of a range. I only want to do questions where these values are between 1 and 10. I can have minimum values and maximum values. I'll go ahead and throw 0 in there, and if I select this one right here, where it's got one parameter, the min value is defaulted to 0. And a little note, the max value is not inclusive in this. So if I want 10 to be the maximum value that I get, then I actually need 11 to be what I throw in there so that I get numbers 0 through 10. So the reason why I have this math operator, I'm just going to hard code it to 0 right now. Eventually, later on, it will be randomly generated between 1 and 4. But right now, I'm going to hard code it to 0. And I'm going to use a special control structure keyword called switch. And my math operator is going to be the thing that I want to switch based off of. So if the math operator is 0, it's going to do one thing. If it's 1, it's going to do another thing. If it's 2, it's going to do another thing. It's a lot faster when you're dealing with lots of stuff that you use a switch as opposed to if statements, because the way the compiler sees it, the way the program builds, it produces a very quick jump to this section of code instead of have to execute this, have to execute this, have to execute this if statement. It's very, very fast for operations like this. So inside the switch statement, we're going to use the case keyword, and we're going to go ahead and throw in 0. 0 is what we're going to use for addition. And we need a variable to hold our answer. And this needs to be a variable outside this method, because if it's inside the method, it only exists in the scope of this method. A only exists in the scope of this method. B only exists in the scope of this method. As soon as we get out, we lose it. So we need a variable right here, which we're going to make an int again, and we're going to call it answer. And so what we're going to do is we're going to say our answer is equal to A plus B. Delineate it with semicolon. Every line in C# has to be ended with a semicolon, otherwise it assumes that it is part of another line. The exception is these squiggly braces right here. These squiggly braces imply a semicolon at the end. Next thing we need to do is update our question label. So label math question, and the label itself is not what we're after. We're after the text property of the label. So label.mathquestion.text. That way what the user sees is what's updated, which is a string data type, a plain text data type. And we're going to say A. Since A is an integer, we need to modify it to a string data type. That way it's plain text readable. Plus, in quotation marks, all string literals have to be surrounded with quotation marks. Oh, I need a plus sign right here to tell the compiler that I'm concatenating the string so it's one big string instead of several little strings. And then b.toString as well, plus quote equals, and then I want a question mark, and I'm going to close my quotation marks, and that's the end of the statement, so I need a semicolon. And I'm getting a syntax error right here. I forgot to add a plus sign right there. So that line looks good. And then after that, I think I can close out of this particular section of the switch statement. So I'm going to throw a break command, B-R-E-A-K, break. And then that tells the compiler that that's the end of the code block inside that particular case if the math operator is equal to 0. And then I'm going to go ahead and throw in a default case. That way, if I have anything else, then the compiler can see that it needs to go to this default case. And within languages such as C#, C++, Java, sometimes you have logical errors that you need to throw an exception for, and you need to let other programmers know that there was a problem. In this case, I don't have anything else available. If I hit my 0, or if my math operator is not 0, I've got a problem. So I'm going to throw, that's the keyword, throw, and I need a new instance of a not implemented exception. And I should never hit this exception right here. Because I'm hard coding things the way I am, this should never happen. But just in case, this is going to tell the program, or tell the operating system that the program's broke, that something went wrong. That way the program can close gracefully or close ungracefully, but can close and give its resources back to the operating system. There are ways to handle these, but that's not in the scope of this lesson. Okay, so if we go ahead and run this program and just test it real quick, we should get a math question pop up. 0 plus 6, okay, good. If I run it again, I should get a different math problem. 10 plus 1, good. 7 plus 8, good. So it looks like I'm getting good random input. Now what we need to do is find a way to have the user check their answer. Inside this button, check answer click, is where I'm going to have the code to do that. So I'm going to use an if statement, and if takes a special data type called a Boolean. It's abbreviated bool. This is a value that's either 0 or 1. More precisely, it's either true or it's not true. 0 is false, 1 is true. And so what I want is if user answer is equal to my answer, now the answer that I calculated at the beginning of the program, right here that I shoved in, so which in this case would be A plus B, then I'm going to do something. Now I'm getting a syntax error right here because this is a text box or a text property, and I need a way to convert that to an integer so that I can check it. So what I'm going to do is I'm going to create a new variable, a new integer. I'm just going to call it uAnswer for user's answer. And I need a way to convert the text box.text to an integer. The integer class has this method associated with it. It's a static method, so I can run it on the class itself instead of an object of the class. And I've got two options. I've got parse, which tries a direct conversion. There's a problem with parse. If the user doesn't enter a number, or an integer, then it's going to throw an error, an exception, and I'm going to have to deal with that. And I don't want to have to deal with that. So parse probably is not what I want. I'm going to use this try parse right here, which is going to yield a bool. If I can produce an integer, then I will. If not, I'm going to throw false. So int.tryparse, and my parameter that I'm going to pass in is this text, and this other parameter is of outInt, type outInt. That tells me, tells any programmer that this method is going to modify this variable result. And so I'm going to go ahead and say out and answer. That way I'm telling the method that I'm okay with it modifying the answer you answer. And that yields a bool that I can check. And when I'm dealing with Boolean algebra, I'm going to use this double ampersand, which is the AND operator. So I want this to be true, and I want uAnswer to be equal to answer as well, and I want this statement right here to be true. The way this is worded to the compiler, it executes this first. If this is true, then it executes this and checks this as well. If this is true, then it goes ahead and goes into the if statement. If this is false, then it doesn't bother hitting this section of the code. It just jumps straight to the end, and whatever's after these parentheses, squiggly braces, is what gets executed. If this is true, then it jumps in here, and if this is false, likewise, since this is false, it'll jump out. But it executes this first and short circuits. If this is false, it never executes this. So now that we've done our check, we know that they gave a good answer. It's an integer, and we know that the answer is matching what we calculated the answer to do. We are going to update the text property of our label. Label graded answer dot text is equal to quote correct. That tells the user that they got the answer right. In the previous video, we set up another label for some statistics. We would like to update those statistics as well, but we don't have any variables for it. So we're going to go ahead and come back up here and int total questions, and I'm going to initialize that to 0, and int total correct equals 0. I think I misspelled correct down here. Missed an R, so I'll fix that. So every time this executes, every time they check the answer, then we need to increment total correct. There's a couple ways we can do it. Total correct is now equal to total correct plus 1. That's one valid way to do it. Here, I'm going to just show you another method for the... Oh, that's not in the right spot. We want total correct to be here, not there. total questions, I can say plus equals 1, which says the exact same thing. I'm suppressing this right here and combining this all into one statement and saying plus equal 1 right there. Another thing that I can do, which is completely correct as well, would be to say plus plus. And that is also saying plus equals 1. I'm incrementing this value by 1. And this is a very common thing to see, this plus plus right here. It's used a lot. Now, what happens if the user got the answer wrong? As it sits right now, it just jumps out of this block and it continues executing whatever code might be right here. We want to do something special if they gave us bad input. And to do that, I'm going to use the else command. And I'm going to update this label right here. And instead of saying correct, I'm going to be snarky and say, you are bad at math. And give them a little bit of snarky input so that they know they need to study more. You can say whatever you want. You can say wrong. You can say study more or whatever you want to say, but that's basically what needs to happen there. And then the last thing that needs to happen in this method is we need to update the question so that they get a new one. Now, we could either do it every time they get the question correct, we could update the question, or we could do it every single time. This particular case, I'm just going to go ahead and do it every single question they answer, they're going to get a new question. So, generate question. So we have that function method call again. If we wanted it only when they answered a question correctly, we would take this and move it to here instead. But this is just a test, math test, that they're going to get a new question regardless if they got it right or wrong. So they don't know what the correct answer is, or they don't have another chance to get it right. The last thing I want to do before I start testing is say the user types in their answer and then they just hit the enter key. We want the enter key in this case to grade the question as well. So I'm going to jump here into this text box, key up. This executes as soon as the key is released. There's different ways you can deal with keyboard input. You can say key down, key pressed, and key up. The key down executes as soon as you press the key. The key up executes as soon as it's released. The key pressed is executed after the key up, indicating that the key was pressed. It doesn't really matter which, in this case, which one you pick. I just figured you'd like to know that there's different options. So what we want to do is check our key event arg right here. It has some information. So E dot, and we have some data associated with the E. And the one that we want to use right here is the key code. The key value is going to give us an integer. It makes it not quite what we want to check, but key codes are really easy to check. And so we're going to encapsulate this in an if statement. If E.keycode, again I'm going to use double equal signs, is equal to keys dot, and there should be an enter key code, which indicates that it was the enter key. If this was executed, then what we're going to do is we're going to call a button check answer underscore click method, which is right here, and we get some parameters that we need. We need a sender. If you press the button, the sender is going to be the button. But since we press the enter key, the sender is going to be this text box user answer. In this case, it doesn't really matter what the object in the sender is, but in more advanced programs, it is better to send the sender. And we need key event args. We need an event arg E that we're going to pass in. Key event args is a event arg, and we can check that by right-clicking it and going to the definition, which pulls up this little file right here, which is an assembly information that gives you information on this class and what you can do with it. Right here shows the inheritance hierarchy of key event args. The syntax, here's our class key event arg. This means I inherit from, and then this can be either classes or interfaces. And we don't really care, but key event args is a class, and so our key event arg is an event arg. So we can just directly pass that E straight in, and the compiler will be just fine with it. Windows will be happy. And now we should be able to run our program. Notice here I put these in squiggly braces. This one I just had a semicolon. The if statement only executes the next statement, and the way to get around that is the squiggly braces. This is what they call a block. And so here it's executing this entire block. Here it's only executing this one statement. Anything past this won't be executed, or will be executed anyway, because when it jumps out of the if. Anyway, our program should be ready to test. We should be able to start it, and we should be getting random questions, and it should be checking our input. 8 plus 0 is 8. Get our correct. I just hit enter to do it. 0 plus 6 is not 8, so I got it wrong. 0 plus 6 is 6. 5 plus 10 is dog. Oh, I got it wrong because I typed in dog. One thing that might be useful is having this clear every time that it generates a new question. So let's go in there and add that to generate random question, and we'll just say, let's see, it was text box and what was our text box called? It was user answer. Text box user answer dot. We could modify the text property directly and set it to something, but we're just going to say clear. That way we dump what was ever there. And so 0 plus 3 is 3. 9 plus 5 is 14. Looks like we're not updating our statistics. So right here, after the else clause, every time we answer a question, we really should be updating our statistics. So let's say our label and statistics dot text And as you're typing with that IntelliSense, if you hit enter, whatever's selected gets pulled. And we're going to set that equal to total correct dot text dot toString plus we're going to tell the user that that's how many they got correct, and we're going to have a comma. We're going to have a plus sign to add more to the string. Total questions, plus sign. All strings need to be encapsulated in quotation marks unless they're a variable. All the string literals need to be in quotation marks. Total questions plus total asked, semicolon. And now we should get 1 plus 3 is 4. Check my answer. Correct, 1 correct, misspelled correct. 1 total asked, looks good. Alright, that looks better. And that's simple addition for you. 2 plus 10, 12. Join us next time where we add subtraction. Have a wonderful day.